This is the sun, the reason you're alive right now. Every breath you take, every drop of water, every living thing on this planet exists because of it. But what if I told you this same star won't protect Earth forever? Because something is changing. Not today, not tomorrow, but it has already begun. Deep inside the sun, a process has been running for billions of years. Hydrogen atoms fusing together, forming helium, releasing unimaginable amounts of energy. This is what powers the sun, what lights up the sky, what keeps Earth warm. But over time, that process becomes more intense. As hydrogen slowly runs out in the sun's core, the core begins to contract, temperatures rise, fusion speeds up, and the sun becomes brighter. Not suddenly, not dramatically, but enough to change the fate of an entire planet.
At first, nothing feels different. Days pass as usual, seasons continue, oceans move, life goes on. But Earth's balance is fragile, and it doesn't take much to push it out of place. A small increase in solar energy begins to warm the oceans, not violently, not in a way you could see, just enough to start a chain reaction. Water begins to evaporate faster. The atmosphere holds more moisture, and that moisture traps heat. More heat means more evaporation. More evaporation means more greenhouse gases, and more greenhouse gases mean even more heat. A loop, a cycle, a process that feeds itself. At some point, Earth crosses a line, a threshold from which it cannot return. The oceans, once the planet's greatest stabilizer, begin to disappear. Not all at once, but slowly, relentlessly. Rivers shrink, lakes vanish, cloud systems collapse, rain becomes rare, then impossible. And as water fills the atmosphere, something even more dangerous begins. Ultraviolet radiation from the sun starts breaking water apart. Hydrogen escapes into space, gone forever. Oxygen remains, reacting with rocks, changing the chemistry of the entire planet. And with every molecule lost, Earth becomes drier, hotter, more hostile, until one day the oceans are gone. What remains is a planet that looks familiar but feels completely alien. The sky turns thick, heavy with heat, the surface baked under relentless sunlight. This isn't a sudden disaster. There's no explosion, no warning, just a slow transformation into a world that can no longer support life. And here's the unsettling part. This has happened before, not on Earth, but right next to it. A planet almost the same size, similar gravity, similar composition. A world that may have once had oceans, clouds, possibly even the conditions for life. And yet today, it is one of the most hostile places in the solar system. That planet is Venus. Because what happened to Venus wasn't sudden. It didn't explode. It didn't collapse overnight. It crossed a line and never came back. For a long time, Venus may have looked very different. Some models suggest it could have had shallow oceans, cloud systems,
Even stable temperatures, a world not so different from Earth. But Venus was closer to the sun, receiving just a little more energy. And that was enough. At some point, the balance broke. Oceans began to evaporate. Water vapor filled the atmosphere. Heat started getting trapped. More heat, more evaporation, more greenhouse gases. Again and again and again. Until there was nothing left to stop it. The oceans vanished. The atmosphere thickened. The surface heated beyond recovery. Today, Venus is hot enough to melt metal. Its atmosphere is crushing. Its clouds are toxic. No oceans, no rain, no life. Just heat, pressure, and silence. And yet, this world started with the same building blocks as Earth, which raises an uncomfortable question. If Venus could change this much, what's stopping Earth? Right now, Earth is stable, balanced, protected by oceans and a delicate atmosphere. But that balance is not permanent. As the sun continues to brighten, that stability begins to weaken. Temperatures rise, ice melts, atmospheric patterns shift, and eventually, Earth starts moving toward the same threshold, the same point that Venus once crossed. And once that line is crossed, there's no coming back. No matter what civilization exists, no matter what technology is built, physics doesn't negotiate. The laws that transformed Venus will apply here too. But here's the difference. We know it's coming. We understand the process. We can see the signs. We can calculate the timeline. And that gives us something Venus never had. A choice. Not to stop the sun, not to change physics, but to decide what happens before that future arrives. Because long before Earth becomes uninhabitable, humanity will face a different challenge: to leave or to adapt, to become a species tied to one planet, or something more. Because in the end, this was never just a story about Venus, or even about Earth. It's about time, about how even the most stable worlds don't stay that way forever. But the story doesn't end there, because the sun isn't done changing. As it ages, its core will keep heating up, its outer layers will expand, and one day, it will become something else entirely. A red giant. A star so large, it will consume the inner planets. Mercury, gone. Venus, gone. And Earth, either swallowed or left as a burned, lifeless rock. The oceans long gone, the atmosphere stripped away, the surface destroyed. A world that once held life, reduced to silence. And all of this starts with something so small you'd never notice it. A slight increase in energy, a tiny shift in balance. The beginning of the end doesn't look like an ending at all. And that's what makes it so unsettling. Because right now, everything feels normal. The sky is blue, the oceans are calm, life continues. But the process has already begun. We're just living in the early chapters of it. And maybe that's not something to fear, because it means we have time. Time to understand, time to explore, time to move beyond a single world, to become a species that continues even when planets don't. Because in the end, nothing in the universe lasts forever. And one day, even the world beneath your feet will be gone.